Imagine millions of space rocks swirling like a cosmic traffic jam, and two of them are about to smash together. Stay with me because in this video, you'll literally fly inside an asteroid belt and watch collisions in slow motion. By the end, you'll know what really happens when asteroids collide, why they don't instantly destroy everything, and how these crashes can even help build planets. Ready to dive into the debris field with me? Quick reality check. Hollywood shows asteroid belts as walls of death. One wrong move and boom. But real belts are mostly empty space. So why do collisions still happen? Let's zoom in and see what's really going on. Picture a giant ring of rubble around a star, like a broken planet that never formed. Thousands of rocks, from dust grains to mountain-sized chunks, all orbiting at slightly different speeds and angles. That's our stage. Now here's the key. Two asteroids only collide if their orbits actually cross. Most don't, but over millions of years, tiny gravitational nudges slowly twist paths until eventually two lines intersect. Smash time. Let's slow down a typical collision. Two rugged boulders rush toward each other in space. Their relative speed? Easily thousands of kilometers per hour. Even a small impact at that speed releases shocking energy. When they finally meet, it's not like two pillows bumping. It's more like a high-speed demolition. Stone cracks, layers fracture, and chunks blast off in all directions, forming a glowing fan of dust and fragments. But here's something surprising. Not every collision is total destruction. Sometimes it's more like a cosmic fender bender. The rocks chip, spin faster, maybe change course slightly, but they both survive. Other times, a big asteroid slams into a much smaller one. The big one barely notices, but the little one can be shattered into a cloud of gravel. That cloud spreads out, becoming a thinner, dusty stream. Over time, these repeated crashes grind big objects into families of smaller fragments. Astronomers actually trace groups of asteroids back to a single ancient impact event, like a family tree of broken worlds. So collisions destroy, but they also create. Those fragments become fresh building blocks. Some pieces can slowly clump together again, sticking through gentle impacts and gravity, starting to rebuild larger bodies. Imagine a region where collisions are just energetic enough to break things, but not so violent that everything vaporizes. That delicate balance can help shape future moons, dwarf planets, and even rocky planets. Now, how often do these crashes happen? Not every minute. Asteroids are far apart. For a single rock, a major collision might only occur once every many millions of years. But remember, there are countless rocks. Because there are so many objects somewhere in the belt, collisions keep happening. It's like saying, you won't get hit by lightning every day, but somewhere on Earth, lightning is always striking. Same idea. These impacts also create clouds of fine dust. Sunlight scatters off this dust, making the belt more visible from far away. Astronomers use that brightness to estimate how many fresh collisions are going on. Sometimes a collision knocks an asteroid out of its stable orbit. That fragment may slowly drift inward, where gravity from big planets like Jupiter or Saturn can sling it toward the inner solar system. That's how some near-Earth asteroids are born. They start as anonymous rocks in the main belt, get hit, nudged, and eventually sent on new, more dangerous paths that cross our planet's orbital neighborhood. Here's a twist. Not all asteroid belts are the same. Around other stars, we see huge dusty rings. Bright dust often means lots of recent collisions, like that system is going through a massive smash-up phase. By watching how that dust changes over time, scientists can work out whether big objects just collided or whether the system is quietly grinding itself down into finer and finer particles. Back inside our own asteroid belt, collisions may have played a role in delivering water and organic molecules to young Earth. Some shattered bodies were rich in ice and carbon-based material. Those fragments falling into the inner solar system could have bombarded early Earth with the raw ingredients for oceans and maybe even life. Violent impacts, but with surprisingly creative consequences. Let's zoom into a single collision again, but from the point of view of a tiny dust grain. You're minding your own orbit when suddenly a shock wave of debris rushes past, changing your speed and direction. That small nudge might send you slowly spiraling closer to the star, where radiation and solar wind push and sculpt your path even more, turning you into part of a broad, shifting dust band. So are asteroid belts deadly minefields? Mostly no. For a spacecraft, the chances of hitting something are tiny, as long as you're not unlucky enough to be right where a major collision is happening. Scientists even send probes into belts on purpose to study these rocks up close. The scars, cracks, and shapes on their surfaces are like a historical record of billions of years of collisions. Every impact leaves clues: fresh craters, exposed layers, strange shapes. By reading these marks, we reconstruct the belt's wild past and figure out how often big smash events have reshaped everything. Now you know the secret life of asteroid belts. Quiet most of the time, but over long ages, constant slow-motion chaos. Collisions grind, mix, scatter, and sometimes unexpectedly help build new worlds. If you enjoyed flying through this cosmic rock pile, imagine what happens when whole planets collide. In the next video, we'll explore planetary smash-ups that can create moons and even reset entire systems. Hit subscribe so you don't miss that journey, and tell me in the comments, what surprised you most about collisions inside an asteroid belt? Your question might inspire the next deep dive into the universe.